Hello and welcome to this MyGCSE Science video about making salts. In the previous video we looked at how you name salts. Remember, the name of a salt depends on the type of acid used and the metal in the substance that reacts with the acid. Hopefully by now you know how to name salts. In this video we want to just check that you can do it the other way around and predict what acid and alkali need to be used to make a specific salt. As we said before, the common acids that are used are hydrochloric acid, making chlorides, sulfuric acid, making sulfates, and nitric acid, making nitrates. So for example, magnesium would react with sulfuric acid to make magnesium sulfate, and hydrogen would also be produced. So if you want to make magnesium sulfate, you're going to have to use sulfuric acid, and you'll have to react it either with magnesium metal or one of the magnesium oxides, hydroxides, or carbonates. Same in the next example. If you want to make zinc chloride, we need to use hydrochloric acid and something that contains zinc. To make lithium nitrate, we react something that contains lithium and nitric acid. Just beware that if you're asked to write an equation in the exam, you'll be expected to know what other products are produced, such as hydrogen, water, or perhaps carbon dioxide. So how do we make salts? Well, we know from the previous video that acids react with some metals and metal compounds to form salts. Some of these salts would be soluble and some will be insoluble. And we need to look at the method to make a soluble salt. In this example, we're going to make the salt copper sulfate by reacting copper oxide with sulfuric acid. So the first thing to do is take your metal compound, in this case the copper oxide, which is an insoluble compound, and react it with the acid, in this case sulfuric acid. While the reaction takes place, we want to stir it and heat it to help the reaction happen as much as possible. We need to make sure that all of the acid reacts, otherwise there'll be some left in the solution at the end and we won't have a pure salt. In order to make sure that all of the acid is reacted, we need to use an excess of the copper oxide. This means that some will be left behind at the end. When the reaction's finished, all of the sulfuric acid will have reacted, so there won't be any of that left. We'll have made our salt, copper sulfate, and there'll be some water formed as well, but there's still some copper oxide left behind because we added an excess in. So you can see in this beaker that we have some of the blue solution, which is the copper sulfate, and we have some of this black solid, which is the copper oxide that's been left behind. So we need to separate the copper sulfate solution from the copper oxide. And in order to do this, we need to use the filtration method. You may remember from the first topic that filtration separates a liquid from an insoluble solid. So we pour the mixture into the filter paper in the filter funnel. The copper sulfate solution will pass through the filter funnel and will be the filtrate that we collect at the end. The excess copper oxide will get stuck in the filter paper and it will be the residue left behind. Now that we've collected our pure copper sulfate solution, we need to transfer it into an evaporating dish and start to heat it to remove the water by evaporation. You don't need to heat it for very long to get the evaporation process started, and then you need to switch off the heat and let any water that's left behind evaporate. If you switch off the heat too late, you might not end up with very good salt crystals, so it's important that you only heat it for a short while and then switch off the heat and leave your dish somewhere warm and dry to allow the crystals to form. Here is a summary of what we've just talked about in making soluble salts. First of all, you need to react the acid with an excess of metal oxide, hydroxide or carbonate until no more reacts. This will leave us with a solution of the salt and some leftover metal substance. So we'll need to filter the mixture to get a solution of the salt without the excess solid left behind. Once we have the pure solution, we then heat it to start evaporating the water from the solution, and this will start the crystallization process. Finally, before all the water has evaporated, turn off the heat and leave it until the rest of the water evaporates. This will leave your solid salt crystals behind. That's all for this video. I hope you've enjoyed watching it and hope to see you again soon on another video by MyGCSE Science.